Thanks for coming again. We have lecture number 3.
I got actually a number of questions from you.
How about we talk about more practical things, like how to configure Docker containers and how to deploy something to the cloud and how to
connect Java to C++ and things like that. That's the number one question. The answer is that
we definitely would like to know that, but like I said in the beginning, I don't feel that my role, the best role for me is actually to be a replacement of Wikipedia or the books about containers and the books about Java. So that would be really sad, I think, if I would tell you the technical details here, taking your time, all of you, because not all of you are interested in Java, not all of you are interested in these Docker containers. So I would rather try to give you the overview of what's going on, to give you everything, all the items, all the topics that you need to know. And then you decide by yourself which one is most interesting for you, and then you go deeper and learn more about this technical stuff. Even though we will talk about technical things down the road, we will talk about Java and design patterns and containers and continuous integration and how to deploy things. Everything will happen.
But not to the level of details
which some of you may expect. So these lectures are not about, low-level programming. That's one answer. Another question was about the grading system, like how to pass this course, how to get the good results. I told you I'm doing this for the first time, so I personally, so far, don't have a good idea of how this should work, but I will find out. I will invent some system, and I will publish it on Telegram before the end of this week. So I cannot do it today, too busy with the preparation for the course, but I'll do it tomorrow or, sometime before the end of this week, so you will know everything. I'll just explain you all the details, how it's going to work. Preliminary, I would like to say that my best practice is to judge people by their results. So I don't want to judge you, I want to judge your results. So probably I will ask you to do something visible, probably on GitHub, some pet project, where you will make the design, you will make the diagrams, you will make the implementation, you will use the design patterns, you will put everything together, you will deploy it maybe to the cloud, and then you send everything, and I will take a look, and if it looks great, then you get a great grade. If it doesn't look great, then you get something else. So that's, in my opinion, that's the best way to decide who is doing better, who is doing not as good as it's possible. So that's the answer for the 2 questions I got so far. Let me try the clicker, it works. So today, the title of the lecture number 3 is RUP, Rational Unified Process. Basically we're going to talk, basically we're going to talk about software development methodologies. A few of you asked me yesterday, asked me about what other things programmers need to do in order to develop the project, because we're talking about the process a little bit, but we never said so far what are the steps. So today we're going to find out what people suggested to us, different scientists, different engineers, over the last 50 years, or maybe longer, maybe 70 years, how they suggested to structure software projects and where to put the design. So design is one of the activities in the development of the project.
Design is, as we discussed on the first lecture, design covers everything.
So design is not something that stays between the idea and the implementation. It's something that goes through the whole process. But still, people suggested us to divide the full process, the full software life cycle, so-called, into certain steps. So we will find out what are the steps, how they should be divided, and where the design stays in. Again, like we did before, we're going to make a break in the middle of each lecture, so we're going to have 3 breaks today. So first step, I will tell you a little bit about software development methodologies. That's what they're called, software development methodologies. Then we will discuss specifically how this RUP or RUP, I don't know, RUP probably, Rational Unified Process, how RUP and some other methodologies, how they work, how they are designed.
Then we'll talk about Agile, Kanban, Scrum, XP, all the new things which people invented
after RUP. So RUP was there on the market, made by IBM and large companies, and then people decided to say, no, we want something else, we want Agile, we want something different, so we'll talk about that.
Then we'll talk about the qualities of good design. So we
know the methodologies, so how these methodologies actually help us to make good design. So we'll talk about the qualities of good design, and then we'll finish. So we're going to spend a lot of time on the discussion of RUP, which I think will help you to understand how design should be done in a disciplined way. And then, of course, like usually, the books, the venues, and call to action.
So let's start with software development methodologies. There were a number of them. They started a long time ago. People realized
that we cannot just sit together and just code. We need to do more disciplined way. It's not like, let's get together in the same room, let's open our laptops, let's code for a few weeks, boom, the product is there. It may work for a small startup. It may work for a small project, which is for 1 week of work. But if it's a project of 1 year, then most probably you're not going to create anything if you do like this. So people realize that we programmers are pretty lazy and we prefer not to work and we're pretty messy, so we create some really messy products. So something has to structure us, to discipline us. That's the key word, to discipline us, to tell us, you do this today, tomorrow you do something else. And we follow the discipline, we obey to the discipline, so we follow the procedure. And that's how the software gets created, professional software. So if you get, after you graduate, you go to the company, and if you join the company, and if you see that in this company there's a process, so something, preferably something, not somebody, but something, some documents, they tell you what you need to do, like today, tomorrow, and how you explain your thoughts, what documents you get, what documents you produce, how you discipline, the communication with other people.
Then you get into a good company. And probably this company produces something.
Some good results. If you get into a team where just let's get a nice smoothie to everybody and sit together and code, and probably you deal with the project which most probably will fail, no matter how much money is there and how much enthusiasm people have. So the first methodology was called waterfall. Probably you've heard this name, waterfall. Who knows about this name? I'm not going to tell too much, so people put all the blame on this methodology. They say waterfall is terrible, it's horrible. I personally don't think so. So I'll briefly explain what it is, because actually waterfall gave us a lot.
Then we talk about RAP, which was introduced by Rational, the company, and then IBM acquired the company. So now we associate this with the IBM. Then we talk about Microsoft Solutions Framework. Microsoft also made some.
IBM had Rational. Microsoft created MSF, Microsoft Solutions Framework, or also something similar, but much more simpler. Then we'll talk about ITIL. This is something that you need to know about a little bit, not very deeply. And then, of course, Agiles, they showed up. So we start with the waterfall. So waterfall basically suggests, which is quite intuitive to me. First, you understand requirements. What needs to be done? Then you design it. You say, I want to do it this way. But let's say we do interior design. I want to design a kitchen for somebody. First, I ask you, what do you want? And the customer says, I want a nice kitchen in a pink color. These are the requirements.
Then I say, okay, how about the design? So I take a piece of paper.
And I say, okay, we put the chair here, we put the table there, the one wall will be pink, another wall will be white. That's my design. The next step, I do implementation. So I hire somebody who will take the paint, who will paint the wall, who will put the chair, put the table. That's implementation. Then I do verification. So what do? I call the customer and I say, how do you like it? And the customer says, yeah, it's pretty much what I like. Well, a little bit move the chair to the left. And then I do maintenance.
Then I say to the customer, look, if you don't like it later, then call me.
Here's my phone number. That's the waterfall. What's wrong with that? I mean, it's pretty obvious. That's how we do things in life.
However, in software development, people started to blame this process later, saying that this is not how it works. But if you put a little bit longer diagram, people call it software development lifecycle, like a larger line. Probably you don't see all the details on the lines, but that's a little bit longer because the software, it may take more steps. I don't actually see all of them, but it starts from some planning.
Not only design, you need to do some planning, you need to include all the budgets, then you do integration, not only testing, but integration, then you do some operations. So there are many more steps which were suggested by this waterfall, and that's why it's called waterfall, because it goes this way or it goes that way, but step by step without returning back. So they were saying that if you do the implementation already, if we paint the wall,
we don't call the customer and say, hey, by the way, pink is okay for you.
Because it's too late, because we're already painting. It's already written in the paper, it's pink. So the customer cannot just stay in front of the kitchen and say, hey, how about we don't do pink, we do blue color. It's too late, we already got the paints, we already got everything, so we just paint. So we never return back, it's just one step, one straight line from the beginning till the end. So that's how this development cycle is.
Then people, that was time ago, and then rational unified process was introduced in order to make this situation a bit better for developers, for software developers, to make it
possible to return back. So rational unified process actually was the first, one of the first, who suggested to do so-called incremental and iterative development. Whoever have seen this picture before? One person. This is two people, a very popular picture, which you should know that this is basically the design of how we, for the last 30 years, design software, no matter what we do, agile, not agile, Scrum, Kanban, whatever. So basically, if you look at it, you see horizontally is time. So the time goes from the left to the right.
From the top to the bottom, you see the activities which we do. There are, if you see different colors, then there are, if I'm not mistaken, 9 activities. Let me check. 4, 5, 6, 7, 8, 9. See, I'm right. So there are 9 lines on the top and the bottom. Each line, why the colors are different to differentiate between lines.
And why the lines are not equal. So the amount of, I don't know what you call it, the weight which you put in each line means how much effort we spend on each activity when we move forward down through the timeline. So for example, take a look at the requirements line, which is in pink, the second from the top. Requirements.
When we start the project, we are actively doing
requirements engineering. So we ask the customer, what do you want? What's going to be the color of the wall? How do you put the chair? Where is going to be the chair?
What's the size of the chair? What's going to be the price of the chair?
Very actively do the requirements. Then we move further. We continue doing requirements engineering. We continue asking the customer, how do you want it? But we're not going to ask hard questions like, do you really want a chair and the table? We're going to ask,
you know what, how about we move the chair closer to the window? So it's still possible to make some changes in the design, in our product, but there are much smaller changes because we move
closer to the end of the project. But we continue doing requirements engineering. So this diagram shows that requirements, they start like this. We actively spend a lot of time on requirements for the project, and then we slowly go down and down and down. So if you look at this line to the bottom, to the right side of the project, you will see that we spend almost no effort, no time on requirements engineering when everything is done. Because it's too late. Everything is ready, so we basically we don't ask the customer in the end whether they need something or we misunderstand it. So that's for requirements. For analysis and design, take a look at the line which we need. We talk about design. So design starts
a little bit later after requirements.
As you see, it goes up actively, then it goes down, then it starts a little bit more, and it just goes down again. The implementation is very active
in the middle of the project.
Implementation, test, deployment stays in the middle.
Actually, I disagree with this picture about the
deployment. I think that deployment has to go in the beginning of the project as well. So we understand the requirements, we make the design, we make some implementation, and we start deploying.
The deployment should not wait till the end of this
construction phase. You see there are phases on the top, 4 phases: inception, elaboration, construction, and transition.
So they believe that deployment should start at the end, closer to the
end of construction phase. That's a little bit too old idea, because right now if you listen to DevOps advocates, to people who talk about DevOps, they will tell you that we need to continuously integrate the product and continuously deliver, starting from the first day of the project. So the moment we start, we need to think about how we deliver. So in this sense, RAP is a little bit outdated. But overall, if you look at this, it sounds really logical to me. And also, RAP suggested to break down the full project lifecycle into iterations. So at the bottom, you see iteration. So they have phases. They have 4 phases always. The project has 4 phases. The first one is inception, then elaboration, then construction, and then transition. And 9 activities. And then they have it in iteration. Each iteration, they suggested to have 2 weeks or 3 weeks, something like that, maybe 1 week. It's very close to what Scrum is suggesting, very close to what Agile people suggested, I don't know, 20 years after RAP. So RAP was pretty much iterative, very much incremental, so I don't see how much Agile actually was a disruption, as they claim. So they say Agile was a complete disruption of the market, so we do completely different things. So look at this diagram, which was introduced long time ago before Agile. It's very incremental, iterative.
What means incremental and iterative?
There are two words which they use, which I would like to emphasize, which many programmers misunderstand. So look at this picture. I found this on the internet. It's very well illustrative in the area of what is iterative.
So on the first line, you see that
we design the car. Let's say we make a car. So this process
on the top line is not iterative. So we make a wheel.
We make another wheel, then we make a box, then we put this together, and in the end, boom, we have a car. This is how we build houses. This is how we build cars. That's the way we do it. In software development, we have to do it differently. We have to build a scooter, then we have to build a bicycle, then we have to build a motorcycle, and then we get a car. So in terms of software, it means, let's say they tell you, we would like to make an Instagram, a new Instagram. So you can say, okay, we're going to spend 1 month to create a back end. And then another 2 months we're going to spend to create a front end. And then another 2 months we're going to spend on integration between them. And then another 2 months we're going to spend on a nice UI design, so we put everything together. Boom, in 6 months or in 8 months you get the product. That's a wrong idea. That's not iterative. Iterative development, it says, next weekend you're going to get the first version.
You're like completely broken. Most buttons will not work. In most functions, all functions will not work. You will not be able to upload the picture. All you can do is just install it on your phone, run it, it will show you the logo type, and that's it. But it's going to happen in 2 days. And
then wait for another week, you open the same app, and there will be 2 buttons which are clickable, and you can upload the photo, but it goes nowhere. So you upload it, it never shows up anywhere else. Okay, then next week you see the functionality where you upload the photo, and then the photo shows up for another user. And then we iteratively go from one version to another for more and more advanced versions. Most people don't understand that. Now, if you go to real software products, you will see that most people try to avoid this moment of delivering the product and assembling the product into one piece. So they try to do it like I said. First we make this piece, the back end first, the front end next, and then we put things together. We shouldn't do it like this. We should do iterative design. Every week, every 2 weeks, we deliver a product to the customer, a product that does something meaningful. And every time it's a bigger product. It's a product with more functionality. So that's what they suggest. Iterative. That's exactly what Rob suggested. And Agile keeps saying the same, iterative. And second
picture, which I also liked, it's the comparison of iterative and incremental.
There are actually 2 words they use, incremental and iterative. So iterative development
is, like I said, first we
make the picture. If you look at this picture on the number 1, then it's a little bit different story. There's maybe not even a woman there, but it's just a picture, which looks approximately like what the customer wanted. And then we refine the product. We make it more, more to the point, more to what the customer potentially wants. So we refine and refine and refine, and then we get to the point number 5. Incremental means that we ignore many of the features. We may ignore some of the features completely. So let's say they tell us that we need the Instagram, and we say, okay, we're going to make it the Instagram, but we decide, how about we skip the back end altogether? Sometimes cut off the big pieces from the functionality, but still release the product. So our development has to be incremental and iterative. This is what RAP is for. If you go to the documentation of RAP, it's a pretty large set of instructions to people who are supposed to work in a software project, for software designers, for programmers, for architects, for testers. And these are just 2 screenshots from the documentations for RAP. This is the screenshot. Maybe you can see that on the left we have the software architect and designer. These are 2 roles which you guys will play if you decide to become software architects or software designers. Not just programmers, but actually designers or software architects. Then you will have to do, if you follow what Rob is saying, then you will have to do the activities which are listed here, like operations design, service specification, subsystem design, many things. And they list with these yellow rectangles, they list the activities which you do. And then with the white rectangles, they show you the documents which you produce. So you can see how many documents they expect the software architect to produce and how many documents for the designer to produce. Not only writing code, but actually producing documentation and doing many different types of activities. I actually thing. So if you decide to become really professional in the software development, then you can pass the certification, which I did maybe, I don't know, 15 years ago. So you know what certifications are, right? So when you just a developer, when you're just a programmer in the, in the university, in the company, you're just a programmer. If you want to prove to the market that you actually are smarter, or not smarter, but you actually have enough knowledge in certain area, then you go to a company like IBM, Oracle, I don't know, there are many other companies who do these professional certifications. You pass the exam, so you go to the testing center, test center, you pay some money for it, it's about $150 or maybe $200, sometimes it's up to $600, and they like in the university, but there's a computer standing there, and computer gives you questions, and you answer those questions, and if you pay right, they will give you some sort of this certificate. So I did the same. I studied Rational Unified Process. I learned how these connections should work, what are the documentations, what are the roles, what are these 9 activities. That's why I remember there are 9 activities, because I still remember there are 9 of them, because I was preparing for the exam. And then I went to the test center. I spent some time, I spent some money. I took about 2 months for the preparation, and they gave me the certificate. I suggest you do the same. Why I'm telling you this? I suggest you think about this not only about graduating from the university, but actually getting for yourself a few certifications. Rational Unified Process, what is the certified specialist or something. There are certifications for UML, for example. You can get the certificate that you're a UML certified expert. It means that you studied UML and then the computer tested your knowledge, and then it means that your knowledge are proven. And then you collect portfolio, and when you try to join the company, you can show them, together with the diploma, Jesus, what's going on? Together with the diploma you have for your higher graduation. So the certificate means that you actually managed to pass the exam. I think it's a big achievement, it's a good achievement for a young expert. Not only diploma, but also the certificate. Yeah?
But what certificates really are? Like, how can we, for example, understand that this certificate is some good one? Because, nowadays there are lots of certificates that you can get on
Coursera. Yeah. How do we know the good certificate is good or not? So, of course, Coursera is not something that you want to get. Coursera is, in my opinion, this is not a real certification. So you get the certificate from a company. IBM, Oracle, the object management group, which gives the certification for UML. So you only consider certificates where personally, they take all your things, all your belongings, they put you in the room, they lock you in the room, there are cameras there, there's one computer, you sit in front of the computer, they check you, like they validate that you actually passed the exam, and then you give the certificate. So that's way more professional than Coursera. Coursera is something that so many people can get, and I would not consider them as real certificates. So for you, the decision which certificate makes sense is actually you just look at the company which gives the certificate. If it's a big known company, then go for it. I think, how many of you are Java developers or want to be Java developers? Oh, that's amazing, just 2 people. And what languages do you use then? Python. Certification, just Google it. Python exists, so you can become Python. There are a few like that, Python Silver, if I'm not mistaken. What else? What other languages? JavaScript. For JavaScript, I don't think there's something exists. Maybe, maybe Mozilla would do something. Maybe already have done that. I don't know. But what else? C. Well, for C, C++, again, I'm not sure because the language is not owned by any company. So, but you can try to check it out. But about process. So IBM, like I said, means that you understand the process. You don't need to be a manager for that. You're the designer. And then you show to your employer in the future that you know the things quite well. And also it will help you to know things, to learn things. It's like this course, but much more intense. Because the course you can attend, you can skip, it depends on your mood. In the certification, if you don't contribute, if you don't dedicate 100%, the computer will just not give you the certificate. That's it. It's pretty easy. And you will waste your money, because they don't return your money back. So you pay like $200, you sit in front of the computer, you fail, and that's it. And then you have to apply again in about a month or something and try it again. So it's very strict. So there's no person there. It really proves that you can do something. Next step, solution network. Microsoft also suggested some framework, some discipline for developers. Again, it's a circle. You know, the most recently developed frameworks and processes, they are in circle, like Agile, Microsoft. You will see now all the pictures, the most of them are circles. So they suggest to go in circles, so iteratively. So you plan, you design, you understand requirements, you design a little bit, you make the implementation, you deploy, you show to the customer, and you start again. So again and again and again. So you make product more and more advanced, and you go circles. You go in circles. The faster you make that circle, the better for everybody. So the circle should take a few weeks, ideally, maybe ideally 1 week. So we understand what needs to be done, we put it in practice, we implement it, we test, we put it in production, and see what the customer says. Circle. Microsoft suggested something similar. You can study Microsoft. I also did many years ago. I cannot say I enjoyed it because RAP is much more professional, in my opinion. Also, there is a Information Technology Infrastructure Library. It's a framework for, not for software development project, but for maintenance of the project. So let's say we have a product already, we deploy a number of containers and a number of servers, and then we need to maintain and ensure that all our solution is 100%, you know, not 100%, but 99.99% available for our customers. So how do we do that? How can we guarantee that the system is up and running all the time? What are the procedures? What are the regulations? What are the steps to do that? Like, what the documents, how we can, you know, who do we call, what the software we implement. ITIL actually regulates that. I suggest you take a look at it. I'm not an expert in this thing. I never studied that. I just know it exists. So every time, please make this system be 100% or 99% available, then the first thing you should refer to is this standard. So you just open that and say, okay, if you want to be serious, I can tell you how we do it. I can tell you what are the steps. I put the 3 pictures there. There are many more. You can go to Wikipedia, for example, spiral development model. Again, the circle, take a look. The V model, the rapid application development, again, the circle. So in most cases, people suggest to go in circles. Everything are just details, like how exactly these circles are designed, but the overall idea is very much the same, very simple. You just make circles and make them as frequently as possible. And design has to be addressed on each circle. So you ask yourself, how good is my design on every circle you make? Every week you ask yourself and ask the team, is the design good? Do we do everything right? Take a look at our diagrams. Take a look at our design patterns which we use. Do we make everything right? I think that it is definitely old. So if you go to your future employer and you tell them that you would like to work according to RAP, then most probably they will not hire you. So be aware of that. So this is something that modern companies don't like. They think that these methodologies, I'm talking about these things, that these methodologies like RAP and this spiral model and Microsoft Solutions Framework, they're all from the last century. And now we're not supposed to use them. So if you bring it up on the interview, then most probably you're going to get into trouble. They expect you to say that you love Agile and everything is Agile and you hate these methodologies, you hate documentation, you love to create the product, you're all about the product. We'll talk about this after the break. But I think that deep inside your mind, deep inside you, you have to remember that how these things are designed in RAP. And remember this picture which I showed you, this one. That we have a number of activities, they all go in parallel, all 9 of them go in parallel. And you need to remember, and you need to make these circles, iterations, and the software has to be developed like this. Every time you show something new to the customer and to yourself, and make sure that you test, you implement, you put the integration tests together, you deploy, and design gets together in place. So Agile, one of the best books about Agile. We will talk about Agile, Kanban, Scrum, XP, and then the final line, I will try to explain why, in my opinion, these Agile things and all these movements in the software development process actually is happening.
So I'm citing one of the best books
about Agile and about software development, which is not so formal as those frameworks and methodologies, but very, very useful, is the book by Robert Martin, who I mentioned before, who you absolutely must read. That's the guy who, all the books he wrote, you absolutely must read if you consider yourself a serious software developer. So he's saying that the idea is that with each iteration, the team improves the design of the system so that it's as good as it can be for the system right now. So that's exactly what I was telling you before. But Agile emphasizes this more. This is the picture of Agile. Again, the circle. Again and again, the circle and the circle. Agile says we start from the requirements, then we go to design, then we go to development, then we test, deploy, review, and look at the requirements again. Nothing new at all. The same circle which existed a long time ago.
But Agile, what they did is they suggested
To cut corners as much as possible. So they are saying this Agile adapts. They're saying that we should not pay much attention to documentation, we should not pay much attention to the process, we just sit together and code, which I think is a good thinking, good philosophy, but at the same time, it's better not to forget about the methodology. So the best way is the combination of methodology, where you know that there's design, there's architecture, there's requirements, and requirements have to be documented, and design has to be explained in UML. And then you look at this situation from an Agile perspective. And you say, you know what, if necessary, I can cut corners. If necessary, I just make a phone call to the customer instead of maybe sending a documentation. If necessary, I do not use the full UML format everywhere, but I can just draw a simple diagram which will explain everything. So Agile is actually suggesting you that you don't try to be formal as much as the process requires, as RAP requires you, but try to be informal and more flexible and closer to the customer. So if the customer is happy with the primitive diagram, then do the primitive diagram. While RAP is actually will tell you, and Waterfall of course will tell you that the process is everything. So if we follow the process properly, if we do all the documentation like it is required, then the product will be absolutely great. Agile turns it upside down. And Agile says no, you don't follow the process to the very ladder. Instead, you just be flexible and let the customer be happy. That's the difference. But the circle is the same.
Kanban. Kanban is the idea of...
If I'm not mistaken, I'm not an expert in Kanban, I'm just telling you this so you need to know that it exists. Kanban is like a methodology or maybe a principle, an idea of how we manage tasks in the software project. So instead of making a project plan, instead of putting all the things into line and then calculating the budget and then making drawing the plans for a week, the plans for a month, we don't do all of that. We just have the Kanban desk, or sometimes it's called Scrum board. I don't know, Scrum is quite related to that. So Kanban desk, that's what I found on the internet. So you put just your user, you see the US means user story. User story, yeah. It's a story of what people, like, remember we talked about use cases, it's something similar. It's a story of what the customer wants to see. For example, the story says, I go to the website, I click the button, I upload the picture, and the picture shows up in the database. That's the user story. So you put this user story on the sticker node, you put the sticker node on the Kanban desk, which is the desk in your office. So you make this desk in your office, you draw these lines, stories, to do, in progress, testing, done. And the whole team stands in front of this desk, and they move these stories from the left to the right. I've seen this many times in real projects. People do that, and it's quite convenient. So we put many sticker nodes there, like on the first column. We put them like 20 of them, or maybe 50 of them. It's a quite large piece on the board. And then in the morning we come to the board and look at it, and I say the color means the person. So for example, my sticker nodes are red. So I take this sticker node and I put my sticker node to the next column and I say, I'm doing it. Or maybe the color can mean person or can mean something else, maybe the
importance, something like that. So I just move this sticker node
to another column, and then tomorrow I come in and move it to another node.
And then everybody can see every day what's working.
So no need to get together and see the plans, no need to write the plans on the document, like planning documentation. It's just a very simple way of planning the work. That's what Kanban is suggesting.
But it doesn't mean that we need to skip the design description. It doesn't mean we don't need UML. It doesn't mean we don't need to
explain our concerns and functional and non-functional requirements. Absolutely not. It's just a way of planning what to do next tomorrow and what to do next week. So we just move these sticker notes from the left to the right. When they go to the far right, then we just remove it and we start from the left. So we again create new sticker notes on the left column. That's it, that's Kanban. Not a rocket science. Next one is Scrum. Scrum is super popular right now in the market, to my knowledge, in America as well. I lived there for 5 years, worked with a few companies, and everywhere it's Scrum, 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 Scrum. So what is Scrum? Scrum, basically, who knows this word, Scrum? You see? Many of you.
So Scrum is like an implementation of Agile. So basically they ask you
To have a backlog. The backlog is a list of tasks which need to be done. For example, all the features we can put there, or all the use cases, or all the user stories. This is a large backlog. And then we take something from this backlog, we sit together and we decide,
what do we do next week?
on Monday morning, we sit together, we open the backlog, and I say, I will take use case number 7. And somebody else says, I would take use case number 5. So we take these use cases, we put them on the table. We do this, sometimes we do this poker planning. Who knows about poker planning? There you go. So we do this poker planning, and then we decide, okay, that's how much this sprint will cost us. So we know that we can do it in a week, or we cannot do it in a week. If we cannot, we take it away and put it back to the backlog. So we have this scope for the week, we call it sprint. That 1 week or 2 weeks or 3 weeks we call it sprint. It's time-boxed planning, so-called, so we plan for the time. So we never go over the sprint. We don't just take the tasks and then we say, okay, there's so many tasks, so it's gonna take us a month. No, we always do 1 week, or always do 2 weeks. So it's called time-boxed planning. So we time-box ourselves and then we put as much as we can into time-box. So we put many, many, many stories there. When we decide, okay, 5 is enough, that's for you, that's for you, that's for you, and we start working on that. We start working, we make a circle. We understand requirements, we improve design, we implement, we deploy, we test, we finish the sprint. Then we get together, do the retrospective, so-called. So again, we sit together, we all talk to each other, how it was, whether we managed to complete, somebody failed, some tasks didn't manage to finish, and we start again. And we do these Scrum meetings every morning. So we stand up in the office, talk to each other.
That's the management of modern software development projects. Anyway, Scrum or not Scrum, it's the same circle.
Requirements till the deployment as soon as you can. In sprints, okay, in sprints.
Next one, extreme programming, which,
as we just found out, I'm absolutely not an expert in. I just know that extreme programming exists. I know that it's about
extremely fast return of your results to the development process.
as far as I understand, and there's also pair programming inside. Who knows about pair programming? Oh, good, like 30%. Pair programming is like I'm sitting next to you, you code, and I just drink coffee. That's basically pair programming, yeah. And then I sometimes tell you, no, that's wrong. And then you just say, just stay quiet, I know what I'm doing.
I've done it when I was a student, I've done it many
Times it was really nice, because while coding you can chat with your friend, you can discuss some other things, then he writes the code, you enjoy, sometimes you change places, but in most cases you keep the same role. So in most situations you are for example, I am the lazy guy and he's the code writing guy.
But actually the lazy guy actually does a lot of work too, because the lazy guy has the different perspective, a different view of the code.
And that person who is the lazy one can actually recommend many interesting things, because when you write code, you get focused and you lose the perspective. So I highly recommend you try this pair programming if you have time and budget. Because if you go to the real company, the real coding space in the modern world, and you suggest that to your manager, then be prepared that the reaction will be, oh, okay, I understand what you're trying to do. You don't want to work. So you want to just sit and do nothing. They will try to avoid this pair programming. Most managers, most companies will consider that as just only one person is typing. And if the second person is not typing, then we get 2 times less result than if 2 people would be typing. So that's the traditional understanding of pair programming, like this negative attitude towards it. Even though my opinion, this is really good, this pair programming. But in reality, you will see that they will try to put you in individual chairs and individual computers. So it's not going to happen. Extreme programming, read about this. Kent Beck, a great author, and you definitely need to know what it is.
And now I will tell you about cost of bugs. Who ever heard about this
problem and about this definition? Okay, some of you did. Cost of bugs. People say, and I agree with them, that the earlier we fix the bug, the less expensive it's going to be for us. So when the bugs are fixed in the requirements document, then the cost of the bug, not the fix, the cost of the bug we introduced at the requirements will be extremely high. So if we detect the bug in the requirements, if we lose the bug, let's put it this way, if we miss
The bug at the requirements phase.
and it goes to production,
If they detect a bug on a stage of requirements, then it's extremely cheap if you fix it on this stage.
right?
And on later stages, it's getting much more.
Right, exactly, yes. So if we detect the bug at the phase of requirements, to fix that bug will be extremely cheap because it's a piece of documentation you just
Cross it out, say, okay, the user should not be able to click the button. The user should be able to upload the photograph automatically without clicking the button. It's an easy bug. You just cross it out in the documentation, boom, a new version of the documentation. If we already designed the system, we already have the UML diagram, we already put the UI mock-up, for example. On the mock-up, we already have the button there. And the button is there for uploading the photo. Then fixing that will require us to remake the diagrams, to redo the UI, maybe mock-ups, to change something. But still, it's doable, it's not so expensive. If you catch it later, when it's already implemented, then it will be much more expensive to remove that button and to improve the functionality, and so on and so forth. The longer, the higher is the price. If we
deliver it to the customer and put it to production, to the servers and everything, then it will be super expensive. So, Agile and all these iterative and
incremental development methodologies, they suggest us, they are made to help us reduce the cost of the bug.
so we catch the bugs earlier, not later.
With Waterfall, we catch bugs at the final step. So we do requirements, we ask what's going to be the color of the wall, pink, we design, we paint, we call the customer comes in and says, no, that's not the pink I meant a different color. Too late. We already spent everything, we already spent the money. If we would buy the color and paint a small amount of wall, a small piece of wall, and call the customer and say, what do you think about this color? And the customer would say, no, I would like a different one. The cost is small, we just buy a different paint and that's all. But if we call the customer later, too late, then the cost is high. That's all about that. That's all about the cost of the bug.
So that's it about these methodologies.
Now we will talk a little bit about what is the good design. If we follow these methodologies, then we're going to create design which is maybe good, maybe not good. I decided to put this topic in this lecture because I think it's related to the methodologies, because the method we use
Actually affects the design we make. So we go through
3. I defined it, I read about that when preparing this lecture. I read about many qualities people think we should put in a good design, and I left only 3. The first one, I think the design has to be simple. So simplicity is the virtue. Simplicity is absolutely something you have to aim for. And I put a number of quotes there, and they say, these people who are extremely respectful in the area of software design, they say that, for example, Kent Beck, we should make the smallest possible investment in the design before getting paid back for it. It means that here he's talking about the investment we put into design. So when you design something, you need to try to design as little there as necessary. I can give you a very good example, which I know from my life. I have a friend who worked some time ago, it was probably 10 years ago, worked in a company which was trying to make a system similar to WhatsApp, a messaging application.
At that time, WhatsApp was just starting, Telegram
barely existed, so there was a good opportunity on the market to create something like that, to create a messaging app and get on the market, get the huge investments, blah, 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 basically acquire the market.
So they were doing it right. He was working, my friend, he was working in this company.
And he told me this story, that they were doing it absolutely right, with the UML diagrams, with the proper design, with a big amount of servers, which are capable of supporting 99.9 availability, with everything designed correctly, with the proper database, with the sharding and the synchronization and backups and everything. So the design was absolutely extremely perfect.
That's why they hired very expensive designers and programmers, so that they do it right. At the same time, WhatsApp was just moving forward, making mistakes, designing it wrong. You know, it was down like half a day or something, but it was moving forward much faster than the first.
And the first team finally got bankrupted and threw away everything. So design was too expensive. The design was too complex. It was over-designed. They over-designed the solution. They invested too much. They invested too much while it was not needed. At the beginning, when the product is young, you don't need availability 99.999. You just put it online, whatever, it goes down, you pay for it. You just put it back online and you give a few dollars to all your users and they will be happy. So you solve your problem somehow else. So you don't try to make your design completely nice in the beginning, fully designed, fully thought through. In the beginning, the design has to be simple and cheap. The cheaper, the better. I can give you another example, which I
said about that many times. I think it's like a public information. So you know the company Booking.com.
You probably use it, right? Who is using it? Many of you. So I lived in some time in Amsterdam, and I had also a friend
who worked in Booking.com. And Booking.com was
famous for absolutely complete garbage instead of the code. So the whole, I don't know what's happening now. I'm telling you the story which is 10 years ago. The whole
code was written in Perl.
And Perl is one of the languages which is famous for its complexity, and not only complexity, but also the possibility to do one thing
in 5 different ways. So in
Perl, that's a language where you can do any operation, anything in 5 different ways. A loop, a comparison of variables, an iteration, a sorting of an algorithm, like many operations you can do this way and this way. And then when I read your code, I don't know what you mean in most cases. So the code becomes very cryptic. And imagine the enterprise system like Booking.com written in Perl. So how did it happen? It was just a bunch of friends who decided to make some money, because when Booking was starting,
there were probably, I don't know, 100 systems like that. 100 of them.
Maybe you don't remember, but 15 years ago, they're like every single programmer was making the system for booking tickets and for booking hotels. It was a hot market. Now, if you join this market, you're probably going to get nothing. But at that time, many companies were fighting for the market.
And Booking was one of them. So they made it in Perl.
I don't know for what reason, because they knew Perl. They never made an analysis. They never draw a document explaining like what are the reasons for choosing Perl.
They never had any UML diagrams, I can assure you.
There was just Perl coding. And it was a mess. And my friend was working in this mess. And they had absolutely no unit tests. Because it was, I don't know for what reason, but probably it was difficult to write them. So they had no unit tests. And they had a policy in the company for programmers.
Don't write unit tests.
Because it's expensive for us. For us, it's cheaper to pay the customer when the system goes down.
They book the hotel, we fail, we charge them extra $100, we don't book the hotel, don't worry, we send them back $1,000. They're happy. Your unit tests are more expensive for us. If you start writing unit tests, you start refactoring, you start improving, you start complaining about the code. We don't want that, that's expensive. We have a budget, they had a budget of something like $1 million a month or something, just to pay customers for mistakes. That's it. And maybe it's not a bad idea. Like, we were laughing, right? Because it doesn't sound like, we should not teach that in Innopolis University. But
that's a business practice. Because unit testing in a system like that is very expensive. If you take this Perl code, you can imagine how much will it take for you to refactor and to introduce unit testing, it's a disaster. So that's what they mean, to make it cheap, make it in Perl, whatever, put it to production. Yeah.
Why a software like hotel booking is that much complicated to be implemented or solved? Like, I've used Booking lots of time, and it's something simple. You just have few functionalities like book a hotel, contact the host, call support. Like, it's way simpler than other, let's say, social media apps. So why would it be that much complex and expensive to test the system?
Okay, your question is why do we need testing at all in Booking.com? It's a quite simple system, right? It should be like easy to write, easy to implement.
Well, I can assure you that systems like that, they are huge inside. They're amazing. They're absolutely enormous.
The size of Booking.com, I cannot even imagine how big it is. It's not only what you see. You only see the
Button which you click and you select the hotel and you click reserve and then you get a reserve. What about the accounting inside? We need all kind of reports.
we need all kinds of summaries and financial reports and marketing reports for people who work inside. Booking, it's a company, I don't know how many thousand people work inside. And all these 1,000 people, they're connected to the database where they can get the data. The marketing team who is trying to promote this Booking.com, so they put their advertising somewhere, the traffic gets in, they want to see how the traffic converts. Some finance people who just see how you book the hotels, they want to see the statistics, the numbers, they want to know how much they make every day. The bank, the
testing team, which is trying to understand what's better for the user.
For example, A/B testing. You know what is A/B testing? We will talk about this later during the course. A/B testing is when you have the system and the marketing team comes in and says, we want the interface not to be blue like in Booking.com, but
make it red. We know it's going to increase our sales volume
by 3%. And 3% is like $3 million a day or something. I don't know how much Booking is making.
But it's a lot. So make it red. What do you answer? You're the technical team, you're the software developer, you're the chief architect. You cannot just say, okay, no problem, it's red now. You say, hold on a second. Making it red will require some redesign. It will take like a
team of 20 people. We will spend like a month on this redesign. Maybe you're wrong. How about we spend this time and then we make it red and the sales drops?
And then what? So that's why we have A/B testing, A/B.
You can Google it, A/B testing. It works like this. You design a little bit in red, and then you show this red to every
one customer out of 100.
So you implement it inside the system, the mechanism which shows that you design to some customers. Probably you have seen it. If you go to Facebook, sometimes you see that for you, Facebook looks one way, for your friend, Facebook looks different. This is A/B testing. So Facebook is trying to give you a different interface and see how you react. And if your reaction is negative, for example, you stop going to Facebook more, like as frequently as you were going yesterday. So they turn it away, just shut it down. So that's called A/B testing. They just show you A and you show the B, and they see the statistics. And that requires a lot of coding on the back end. So the system has to be prepared for that. When the marketing team is coming to you like every day and saying different things, like, hey, change this, change that, let the people
pay with not only the credit card, but with the check or with the PayPal. Try it. We're sure it will work. It will give us another
$5 million every month. And you need to adapt to these requirements. And for example, this A/B testing, it's quite heavy for developers. And many other things. So Booking.com, or Facebook, it looks simple, or Twitter.com. So Twitter, it's extremely simple platform. It looks simple, like what it is. Like I post a message and everybody can see the message. I can implement this Twitter over a weekend. I mean, it's most of you can do that. No need to be a scientist for that.
But when you continue with the Twitter, and you
spend like a few years with the Twitter platform, it will be extremely complex inside and very simple on the front end. So the message here is that you keep your design simple. So don't try to design the full system like you're already...
Like already you have $1 billion in your investment. You need to make it
absolutely big for everybody. No, think now. Think about the design which you currently need for 5 users. Yeah.
I have a question. Where is the border between expensive unit tests and everything like that, and expensive maintenance after that? Because the design should be simple, but it should be good.
Yeah, the good question is like, how do we draw the line between
making the design simple and basically not professional, and making it professional, making it right, and making the decision that, I think that a professional designer, somebody who knows how to design big systems, who knows how to draw UML diagrams and how to write proper documentation about design, who knows how to use all the design patterns, that person can cut many corners professionally.
Design something very simple, but having in mind
that eventually this system will grow to a bigger one and we don't want the mistakes which we will not be able to fix later. So for example, when I start designing, I know that, I know that, for example, for this system, it has to be relational database instead of NoSQL database. I kind of feel, and this decision, I know that this decision is important. Let's put it this way. So I know that this decision, I cannot cut corner at this decision, because changing from relational to NoSQL,
That will cost me a lot later in a year.
so on this decision, I pay a lot of attention. How the UI will look, I care not much about that, because I know that in 1 year, when we get the money, we hire good designers, UI designers, and they will redo the whole front end.
But I know that it's better to separate
The front end from the back end right now, starting here. So some decisions, I feel that these decisions will be extremely expensive if I make them wrong. But some decisions, I know that they are easily changeable. So it's about a person who've been there. So you have to be there at least once, so that you know what it's going to be for you, how much it will cost for you if you make the wrong decision here. So it's difficult to draw a line and tell you right now, like, look, these are the list of decisions which are not acceptable to ignore. All right?
So that's the first. It must be simple. I told you 2 stories about that. Probably they will teach you something. The second one, that's a funny story I want to tell you.
So I found on the internet this picture which is showing how this complexity. So when I say simple, I'm talking about complexity. So the complexity is supposed to grow.
It's complexity of the design, complexity of the system, and it's supposed to.
People think that complexity of the system, when you start designing it, in the beginning it's simple, and then it grows up to no limit. This is I found on many places. I just show you one picture which I found on the internet. They also put this, so you see horizontally we see features, so the more features we add, the more complex the system becomes. And the usefulness of the features goes down, because there are more and more features, and people use less and less of,
People don't use all of them, so usefulness of one feature goes down.
and there's another line which shows how many bugs we have in final product. So in the beginning we have not so many bugs, then the amount of bugs grow, and then it gets stable and stays the same.
I totally disagree with this picture.
So my personal experience tells me that it's wrong. It's not happening like this. I don't know where did they get this picture. Maybe they work like this, but in my opinion, it works like this. And I found actually a very good blog post about that. That's the link, where the guy explains exactly what I feel in my projects. So in the beginning, when you start,
But he's talking about perceived complexity.
he's talking about the complexity, how we feel the complexity of the product, which is close to the real complexity. So when we start the product, start the development, we usually, what I do, it's my most people do, they think that the system is too complex and they need a super good design and a super sophisticated design. So they start making design very complex, like many UML diagrams, they think about many databases, they think about back-end, front-end, multi-layer architecture, how many objects, how many components we're going to have. So they overthink the design.
It goes up like this. They create many different classes. They make this inheritance. They over-design the system. The complexity goes up. Then at some point they realize that that's too much. We don't need so many. For example, I need an Instagram, and I say the person will be able to click the button. I upload the picture, and I say, oh, they will upload the picture. It has to be one graphic, one format of the picture, another format. How many formats do we have? Let's go to Wikipedia. Oh, we have like 70 formats of graph of picture. Okay, we need to support all of them, because who knows what the user will upload. So we implement the system which supports all formats of the graph, of the graphical information. All picture, GIF, PNG, JPEG, blah, 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 many of them. And then at some point we go up, and then we sit together in a few weeks and then say, like, why so many?
Like, who cares? Let's just do one. And everything else, okay, the first version will not support it. Like, let's focus on one. And we start deleting these classes which we designed, these components, everything is unnecessary. We just need one class. That's all, or maybe one function, which will take the graph and the image, which will take the image and convert to something else, to some data. So we start to remove complexity. That's what's going on the graph. So we move from the point 1 to point 2. We just drop, the complexity drops. So we remove things out.
And then eventually we realize that we removed too much. That actually we were right about that. That actually one format of an image is not enough.
How about 2? How about 3? Okay, we don't want 70, but 3 is probably what we need. And then we return back. then we say, oh, you know, we deleted the class, let's get that class back from the Git history. So we find the history, we return something back which was deleted, and then we find some place where the complexity is enough, and then it starts going slowly a little bit down, 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 because we start understanding that the system is, you know,
It's not so complex for us anymore, and we
the complexity of the code, in my opinion, when I work with the code, the complexity of the code also goes down. If the design is right, if the code is clean, then the more you work with the code, in my opinion, the less complex it becomes. So probably this is how it should be, in my opinion. This graph is much better than the graph where we say that we start from a not complex system and then it goes up and up and up and up. This is a disaster. If you do it like this, if the complexity grows, like on this previous picture, the complexity skyrockets, then at some point you will be dead. The system will be dead, so you will not be able to support it. So you need to think how the complexity should go like this. It should start, the complexity is the highest, and then it goes like this. So read the blog post and try it yourself. And this is my quote. I quoted it from one of my blog posts. I'm saying that I wrote this blog post, quite a moody blog post, where I was very unhappy about some project. I don't remember, it was a long time ago.
But I probably met the architect who
Was very proud about high complexity of their diagrams, of their design. So I remember that we're sitting together in the meeting room, and they were showing me their diagrams, they were showing me their pictures, and saying that
it was complete mess. It was not UML, of course.
it was just rectangles everywhere, absolutely unreadable diagram. And I was sitting there, I was joining the team, and I was looking at it, and I was asking questions. And in most cases, the answer will be, it's hard to understand. Yeah, we know it's hard to understand. Like with a proud attitude. So we know how hard it is to understand for somebody like you, the architecture which we created.
So they felt extremely proud of that. And I wrote a blog post saying that
I think it's a completely wrong attitude. So the good architect, the good designer has to be proud about simplicity, has to be proud of something which is simple. So if I make a diagram which anybody in the room can easily understand in just in a few seconds, then I'm a great architect. But if I make something that nobody understands, for example, I give you the lecture and you don't know what I'm talking about, I'm probably not a good lecturer in this case. So something is wrong with me, not with you. But most architects which you will meet when you go to real companies, they will be like that. They will be very proud of their complexity. And you will have nothing, you will be not able to do anything about it.
What's the best practice to architect our software? Not to underestimate, not to overestimate our complexity.
yeah, the question is how to avoid overestimation,
Complexity and how to avoid under complexity. I think that the best way is facing the production as soon as possible. So you design something, you put it to production, you look what the customers are saying, how your product fits in the production platform, and if it works, then you're happy. So your job, actually, the job of each cycle, which we discussed before, or each cycle of the process, is actually to, in the minimum cost, put something to the customer's hand. So this is your job. As soon as possible, with the cheapest investment, using just one cycle, just do something and put it to the customer. And of course, don't do
less than that. So if you have space, if you have
time, for example, you have 2 weeks, and you know that you need to implement just
one button, which is clickable, then probably you can
spend some time on some UML diagramming and some thinking about good architecture, because you have enough time. If, for example, on the other hand, you have 2 weeks and you have to implement 5 different features, then of course you don't have time for thinking about proper design and something. Then you cut corners and make it as cheap as possible. So look at the speed of what you can, look at the speed at which you have to deliver the product to the customer. I would recommend be thinking like that.
Second quality of a good design is
do not repeat yourself. It doesn't repeat itself. So that's a huge problem for all programmers when they write something twice. You know, copy paste, right? When you take from one part, you paste it to another part, and then you call it a day because it works. It worked there, so it's going to work here. So do not repeat this repetition of the
code. Redundancy is extremely big problem for software development. Extremely. So your design, if you design something And then you go to another place in your application.
And then you design, and you feel that you design something similar or even the same,
And then you do it the same way, you just copy this design, you just
copy the same, and then it's a completely wrong idea to continue like that. So you have to stop and say, okay, how about we take this functionality to a module and then use this module from here and use it from here. So copy paste is absolutely not the way to go. It's the second problem of design.
Number 3, it must be modular.
The design has to be modular. It means that, like Robert Martin says, design is immobile, so you can't move it when it contains parts that could be useful in other systems, but the effort and risk involved in separating those parts are too great. So, like for example, you design a system, and you have an array of numbers in your system, and then this array of numbers has to be sorted. So you implement a sorting algorithm. But the way you implement this algorithm, you make it the way that while sorting, it touches some other pieces of the code. So when tomorrow I come in, I
cannot take your sorting algorithm and use it in another system.
Because it's very much coupled with your other pieces of the code. So you don't make your code, you don't make your architecture, your design modular. It has to be modular. So I should be able to take almost any part of your system and reuse it in another system. You implement one algorithm, make sure it's isolated from from everything else. It's
extractable to another place.
An algorithm, module, a storage, a translator, a converter, a listener, all the pieces, they have to be extractable. That's what this is about. Most people don't do it. Most people, they do monolithic design. So this
is the whole big black box which works together. If you want to extract something, no, that's
not possible, maybe later. So you come to them and say, how about we take something from here and make it open source? Oh, that's too hard. Everything is so connected to each other, we cannot do it. And they're so proud of that. They say, our system is so big, so complex, so you cannot take anything and make open source. It means they're bad designers, it means they're bad architects. So it should be possible to take almost any part and make it open source. And that's actually how we make, again, another story, that's actually how it happens in enterprise, in big corporations, when you want to go open source. So in most cases, who of you are actually open source developers? Who does something in open source? One person, two maybe. Yeah, well, you have to. I mean, you have to think about this because the world is moving open source. So you have to think about this now. You have to either develop your own open source projects or you have to join some open source projects and contribute there. So that will give you a huge leverage against other programmers when you will start finding jobs, when you will start finding employment. If you are an open source, then your value on the market is higher. That's for sure. So when in a big company, when when we have a huge product, and then we would love to go to open source, for example, we have a team of 10 people, we work together, but then we decide, something has to be open source. We're tired of working in-house, so we want to
publish something
to the public place. Then we should be prepared for that. We should have those pieces which can be extractable. We take it, we move to open source, and in most cases, your company will allow you to do that. Let's say tomorrow you go work for a big bank in Russia. And this big bank, they have big, large software systems which absolutely cannot be open source because it's a bank. So you cannot just tell them, hey, your boss.
Let's put everything to open source. It's such a great code. Let other banks use this code. They will just laugh at you. But if you say, hey, you know what, we have a very interesting
piece of software inside our mobile application which does image conversion. How about we make it open source? What's bad it's going to give to anybody? Image conversion. We don't disclose any financial details. No other bank will contribute, will benefit from that. It's for everybody. Any company can use it. How about we take this image conversion module and make it open source? If it's ready, then the boss will say, okay, no problem. How much is it going to cost? And you will say, no, I can do it over a weekend.
I can just extract it, move it, that's it. If it's so easy, good.
But if you will say, yeah, that will take a month of work because it's so much wired to other pieces, to other modules, it's so much connected to other pieces, then nobody gonna approve this work for you. So make your design modular, that's very important.
Okay, that's it. We have 5 more minutes, so I'll give you about books, venues, call to action. Books first. These are I have 4 books. So these are 2 books which are interesting to read. The first one about racial unified process, you will enjoy it. It's quite interesting to read. The second one, the book by Robert Martin.
I told you many times, Robert Martin is the writer who absolutely has to be known by you. You have to read at least one of his books. This is the book which I think, this book will actually say a lot of things about design, which I mentioned today, but in a much better, with much more details and much better than I can do.
These 2 books, also another book again by Robert Martin. This is one of the recent books.
He published probably 3 years ago, Clean Architecture. It's extremely popular already on Amazon. It's #1 book in the area of software architecture, where he explains how we're supposed to design things. So if you need to know what is software design, you just read this book. You don't need this lecture, you don't need teachers, you don't need YouTube, you just need this book, I believe. He's a very good author. And
Code Complete, this book is very old.
it's, you know, it's probably 15 years old, this book or something, by Steve McConnell. Very, very, very good about software design.
Oh, sorry, I have 2 more. Two more books. One is
Frederick Brooks, Mythical Man Months. This book is probably older than me. He wrote this book long time ago. This is a quite philosophical book, a book about software development.
not so easy to read. The English is quite sophisticated there, but I still recommend you to at least to know about this book.
Who knows about this book, Mythical Man Months? You have to know. It's classic. It's something like people will refer to this book many times. He talks about estimating the software, the philosophy of developing software, and so on. And this one, The Pragmatic Programmer, David Thomas, and even I don't remember the name of the second author.
So The Pragmatic Programmer, also a very good book.
Also not so much into the coding, but also about the coding. But you need to know this book.
Where to publish if you will be interested in actually
Writing something about the process of how to organize work of developers, work of programmers, then this is the conference to go, International Conference on Software Engineering. It's #1 conference for people who invent something in the area of process.
and call to action. What I suggest you to do,
That's like a homework. And you're asking me about the grading, so I think that I will put into one line all these call to actions, which I gave you yesterday. I gave you 4 of them, so this is number 5. So probably I will put them all into one line, and you will be able to go through them, like read them one by one, and implement something yourself, like some home application. And I will ask you to make it open source. So by the end of this course, maybe all of you will become open source developers, and maybe some of your applications will actually earn some stars on GitHub, and maybe that will be the good start of the new career for you. So we'll see. So now I suggest you to break down the development of your app into 4 interactions. It's supposed to be iterations, sorry. In 4 iterations, and specify the functionality to be delivered by the end of each of them.
so let's say you have an application which you are planning to develop. Before developing it, try to break it down into slices.
Into iterations. And say, by the end of this iteration, my application will do this. By the end of the second one, my application will be able to do this. So yesterday, during the first 4 lectures, we discussed how to design everything. But now, how about we slice it down into iterations? How about we think about how to design the system with the version number 1, version number 2, version number 3, version number 4. Try to do it. You will receive 4 specifications, 4 sets of requirements for your app.
And the final slide, usually like unresolved issues.
So what is still, in my opinion, not resolved in the area of process? So I suggest to think in this direction. First of all, how can we restrict design automatically? So people do the design, they put the diagrams, they do whatever they want, they make something simple, something complex. So how can we make a computer look at it and say, you're over-designing, or you're under-designing? Maybe AI can be involved, maybe some robots should be able to look at the design and suggest that, hey, there's something wrong with your design. How can we restrict your activity?
Number 2 is the question, how can we
Decompose the task of the design. It's more or less simple to decompose the task of writing code. let's say we need to implement 15 different features. So I can put 50 programmers, 50. So I have 5 features, for example, and 50 programmers. And I can break down more or less easily how the implementation should be done, if the design is ready. So I know there should be like 100 different classes in Java, those are the components, those are the interfaces, so I can give this job to people because the design is already in place. So I see the UML definition of the design, I see the pieces, so I can give those pieces to people, and they will, maybe even in parallel, they will do the coding. But making the design, that's the question. How can we decompose it into many people? So let's say I have not 1 designer, but 3 designers. How can I tell these 3 people to design? Let's say I have 3 designers and 1 kitchen. So how can I decompose the work of designing the kitchen between 3 people? So you will design what? A chair, you will design a table, that's hard. So right now I don't think we have a solution for this. Number 3 is how we can coordinate this process maybe by robots. So if we can decompose it into pieces, this design process, so maybe the robots can automate it somehow. And finally, the final question is how to enforce good design. So we have so many books, we have so much literature about that, but we have very few systems which are in good design. So how can we actually enforce good design? Not just write papers, not just write books about that, not just tell people in lectures what is good, what is not, but how can we actually enforce the good design? That's the question with probably no answer so far. So that's it for now. We have a break, 10 minutes, maybe 15, and then come back. Thank you.